Assalamualaikum and hello everyone. In this lesson, we'll learn about the modulus and argument of complex numbers. Two very important concepts that describe the size and direction of a complex number on the Argand plane. Previously, we plotted complex numbers as points. Now, we'll describe how far those points are from the origin and at what angle they are located. Let's begin with definition 1.5. The modulus, also called the norm or absolute value of z equal to a plus bj, is written as the modulus of z and defined as square root a squared plus b squared. It is just a distance from the origin to the point AB on the Argand plane. So, if we have z equal to 3 plus 4j, then the modulus of z is equal to the square root of 3 squared plus 4 squared will give us 5. That is exactly like using Pythagoras theorem. Next, the argument of a complex number. The argument, denoted as theta, is the angle between the positive x-axis and the line joining the origin to the point representing z. This angle tells us the direction of the complex number, but remember, we must identify which quadrant the point lies, because the arctan only gives the acute angle. Refer to this figure. Whenever the real part and imaginary part is a positive part or has a positive value, we know that it should be at a positive quadrant. Whenever the real part is negative but the imaginary part is positive, we're going to refer to second quadrant. Whenever we have both negative, it's going to be third quadrant, and when we have a positive real part with a negative imaginary part, it is at a fourth quadrant. Always sketch the point first before deciding theta. Let's look at example 1.10. We'll find both modulus and argument for each case. Let's first look at A, 2 plus 2j. Here, the A is 2, B is 2. So, for this case, the modulus should be 2 squared plus 2 squared equal the set of 8. For the argument, the theta is equal to arctan 2/2, which gives us 45 degrees. Right, if you try to look at this, okay, so this is the r, or the size of this direction from origin to this line, which is set 8, and the theta, or the angle of this line from the positive x-axis, is equal to 45 degrees, and we take it literally because it's on our first quadrant. Now B, -2 plus 2j. Modulus of -2 plus 2j is equal to -2 squared plus 2 squared, which will give us also set 8. But for the argument, okay, the argument is sort of similar, which is -45% Celsius, sorry, all similar to A, but because of it has a negative real part, but positive imaginary part, it should be at the second quadrant. It should be at the second quadrant. This part, right? Second quadrant. So graphically, this is how it should look like. So we have this line. Okay, this line, we know that the size of this line is 8. Okay, and the theta is -45 Celsius. Right, we have it negative, right? It's not important, but we know it is 45 degree. So this 45 degree, right, is at the second axis. So from the x, this is how it should look like. But remember, in finding theta, it should always be from the positive x-axis toward the line. So this is the positive x-axis, and this is the line. So it should be this angle that we should seek for. So how do we find this? The answer is 135. Basically, we know that overall this semicircle is equal to 180, right? The whole thing is 360, but semi is 180. So 180 minus with 45 will give you this, right? So this is what we did here, and that's how we get 135. Okay, now for C, -2 minus 2j, it should be in the third quadrant. So as you can see, it has negative real with negative imaginary. So the line should be at the third quadrant. So it will have the same modulus because they have the same number. But let's look about the degree. Okay, it is still 45 degree, but that 45 degree should be at the third quadrant, and guess what, the 45 degree should be here, right? So again, what is the actual degree that we should give as the answer? It is not this 45 degree. What we should give is that we should give this 45 degree plus with the rest of the angle that start from the positive x-axis. So we should give this plus with this. So basically this will be the degree that we should look at. So let's try to look at the answer directly. See, so we have 45 degree as the theta, the initial theta, but then we want to find the angle from the positive x-axis. So from this part, so we go toward this line. So we know that for the initial part here, the semicircle here, it is 180. So 180 plus with 45, that will give you 225 degree. So that is the angle for C. Next, D. 2 minus 2j. For this case, we have positive real part and negative imaginary part. So we can expect that the line will be around the fourth quadrant, and whenever we want to find the angle, we should start from the positive x-axis, which is here, till the line around the fourth quadrant later. So let's look at the answer. So it is the same value of imaginary and real part, so we can expect it has the same modulus, which is 8, and the same angle, which is 45. But this 45 is actually this, right? Let's look at the answer. Right, so for D, what is it, got 45, the 45 degree is from the x, right? This 45. So what we want is the degree starting from the positive axis counterclockwise till you reach the line. So how to do it? We know that the whole thing is 360. So of course we do 360 minus with 45. Right? So that will give you that this is 315. So that is the theta for this question. Notice that they have the same module but different angles. So they are actually symmetrical around the origin. Sometimes we are given the argument and need to find a missing value. For example, the argument of p plus 4j minus 6j equal to pi over 4. So firstly, we will need to factorize this out. So it becomes p minus 6j. So by right we have the the point, actually we have the standard form of complex number, which is a and b. Right, so this one is it a and b. Okay, so using the arctan formula, b over a equal to pi over 4, right, you substitute b minus 6, this, right, this b minus 6 for b over 4, and then this is a bit of properties that you might need to refresh a bit later. So we have the arctan move to the right side, become 10, and then 10 pi over 4 is equal to 10 45 degree, and then solve for p, which will give you p equal to 10. Try these quick exercises after this video. For each complex number, find the R or the modulus and the theta. For example, if z equal to -2 minus 4j, find the arctan of z. Then do part A and D as practice. But make sure you identify the correct quadrant before calculating theta. So, to summarize today's lesson, the modulus of z is equal to the square root of a plus bj. Sorry, a squared plus b squared. Right, this is the set, this is the modulus of z. The argument is equal to the arctan b over a, that gives direction. Right, this will give you a size or distance. This one will give you direction. Together they describe the position of z in polar form, this polar form. The next video will combine these two ideas to write z in polar form using r and theta. Thank you.